Okay, while I'm in the thick of it, in the middle of working through these VGA issues, I wanted to share how I'm debugging this, which I'm very excited about actually. So I can't figure out why when we switch to, here I'll show you what it looks like currently. If we run the OS, everything compiles and we run VGA and it switches modes and then it switches back, but then I can't do my screen stuff anymore. It's not printing to the screen. I have a feeling it swapped and turned RAM enable off or something like that. So I'm going to check the fields, right? How am I going to do that? I'll go into the VGA info function, but I can set breakpoints, which is awesome. So I'm going to do run debug, and it does everything the same, but it doesn't start QEMU right away. And then I'm going to say break VGA.c on line 69. I'm going to continue. Continue. And then in here, I'll type VGA. It's going to run the VGA subroutine or whatever, and it's going to come to right here and it's going to break, which is great. And now I'm going to say step into VGA info, and I can, oops, I didn't mean to do that. But basically that's how I'm stepping into functions, figuring out what values are going on and all that. So I thought it would be useful to share. Okay, whoa, this is massive. Here it is, check it out. If we do os.py run debug again, and we do break on VGA.c, line 69, continue, type in VGA, wait for it to come back, and we're going to step into it. We're going to say next, 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 next. We set RAM enable, right? We're going to print RAM enable. It's 0. This has to be the problem. It's ignoring RAM. We're still writing to the memory, but it's ignoring what the CPU is writing to memory. It's ignoring the memory mapped I/O that it has with the CPU. Somehow that gets turned off automatically. So maybe if we turn it back on, we'll be in good shape. Okay, now this is exciting. Watch this. We had to set RAM enable back. We had to set the memory map back. And now when we run VGA, it comes back and we can do commands again. That's amazing. Wow. Who would have thought that was possible? Whew, crazy. Here's a quick demonstration of the PageKey system as it stands. VGA info is new, ls and clear are the same, and if we type VGA, we get some funny looking screen, and we can hit escape to get out of it. And here's what PKOS looks like on a real system, real quick. We get grub, and we get PKOS, we can do help, we can do VGA info, and we can do VGA. But this one pops right back, so escape does nothing because it doesn't stay in VGA mode for some reason. Gonna have to check that one out. So for OS19, we've returned to the problem of VGA not working, made tons of improvements, and other changes to the code base that will be useful down the line. So VGA has no more copied code. Before I used some copied code that I didn't entirely understand just to get it working. I removed that and now am manipulating registers directly in VGA using input and output bytes to enter graphics mode. And on real hardware, I tested it out on my laptop over there. It immediately pops back in QEMU. It looks really messed up, and I wasn't having much luck doing any drawing. So I wrote up issue number 11 to address that, and we'll tackle it later because there's so much in this merge request now that I feel like it just has to be talked about and then merged, and can take a third stab at VGA in the future. But for now, you can type VGA to enter graphical mode. It doesn't look like much, but once you're in it, you can hit escape to get out. So the issue that is addressed here was to avoid getting stuck in VGA mode, which we now no longer do. Along the way, made some improvements to the standard lib, if you could call it that. The print line, and string equal methods required the string length as an input previously. I thought that was like a secure thing to do, I guess. And I guess it is in some ways, but now I added methods that don't require that. So there is the risk of an infinite loop happening, but for now, it's a lot easier than typing in the exact length every time. Also wrote integer to ASCII functions so that there's a way of debug printing to the screen, numbers if needed. Added a new module, the memory module, which this is actually pretty exciting. Memset and memcpy were surprisingly difficult to implement, but I was able to use assembly to get some semblance of them working using the string instructions in x86, so rep move string byte rep store string byte, and I've tested it out. It's working. I'm using it to store all of VGA memory, in the case of memcpy, in high memory space in text mode so that I can restore it when I come back. And I think what the problem was, why the black screen was observed previously, was because all of the color bytes were written to 0, which I think was having black on black text written. So it's not that it wasn't doing anything. It was writing the text to the screen, but you couldn't see it because it was black on black text. Either way, memcpy copies it into high memory and we restore it, and it's fine. Memset is used to set 0 bytes for the VGA memory to clear the screen, at least at first, but that's not working, so that needs some work. Got debugging down to a science. I'll show a video of how I was using GDB to debug the code, fixed the run debug build. Debugging symbols were not included because I forgot to transfer it over into the new build system, but I figured that out and added it back in. So we're good for debugging. It's pretty straightforward to do again and kind of fun. So I also wanted to share my Obsidian notes on VGA. I did a lot of Googling and had to take some notes as I went, and I think I'll just probably copy and paste these into the blog post if you want to take a look at them. Ended up doing a ton of Googling, and QEMU has some really good info on their site about how they emulate devices and how they represent memory. So those were really interesting reads, and found some information useful for a hard drive video eventually. But commands to save physical memory and then go back through it in a hex dump using ghex, all kinds of interesting stuff. And what else we got here? How to check out the memory map in QEMU, what are the arrays. Free VGA, osdever.net free VGA is the source for this, in my opinion. It's got so much good info, all about all kinds of stuff. Also, Ardent Tool of Capitalism was a really good read. Their video modes, VGA video modes thing, tells you all about how the timing works and that sort of thing. Really good info. I think it was written for IBM, very IBM focused site, but applicable, and tells about how the electron beam works and all kinds of stuff. Yeah, x86 string instructions, all these things that I had to go through and figure out are going to be in the notes, so you can check those out. So here's the merge request. Quite a few changes in this one, so we'll walk through them as quickly as we can. I mentioned that I fixed the build run, so that is right here where we have debug symbols included, and if we do that, we compile using debug symbols, and run debug now uses debug is true. So that's it. Standard lib now includes this I2A method, and yeah, it took me a while to figure out how to do this in C without messing it up, but basically as you go, you just take the modulus of whatever it's currently at for that number, and that gives you the current number. In the case of hexadecimal, it might be greater than 10 for that digit, so you just add the A character to convert it. Otherwise, you add the 0 character value to it to convert it. So this is just taking the ASCII value for the smallest part of the character set that we're targeting and adding it, so that if it's a 0 value, then you just get a 0 character. And if it's anything greater than that, obviously all the characters are sequential, so a 1 character is equal to the 0 character plus 1, so it works out. Same thing for A through F. And then you divide by 10 to get the next one. Integer division obviously just truncates any remainder, so you just move on down. Maybe not the best explanation, but you get the idea. And then just swap the characters to reverse the string, because we're kind of going through it backwards up here. And then add a null terminator, and if there are 0 digits, just return a 0 instead of an empty string. And so that's generalized to which base you want to use. So I set it for 10, 16 for hex, and 2 for binary. And then string equal is actually a really straightforward function. If you're not trying to be careful about it with the buffer sizes or whatever, you could just zip through the string until you find a null character. And if you get to the end, and then they're equal, otherwise not. Terrible sleep implementation is just sleeping by keeping the processor busy counting ticks for a long time. This is really bad, so I didn't want to call it sleep. I called it terrible sleep implementation because I know there's a better way to do this. I just can't figure it out right now. I just needed that right away. And then that's just the header file. And then kernel.c added, first of all, fixed all of these where you have to have the length to compare strings and to print things just deleted all of those, and then added VGA info. It changed VGA test to VGA enter because there's now an exit when you hit the escape key down here. So you can get out of VGA mode now, finally. And then just noted escape key. Here are the memory functions that I was talking about, where you can use these string functions built into x86 to quickly move bytes around in memory. I think it would be faster if I wasn't using bytes, but if I was using words or double words when possible. But for simplicity, I just went with bytes. And if we run into performance issues later, which I don't know if that's ever going to happen, then we can cross that bridge when we get to it. And then here, we're basically just including the assembly into a higher level. So I wrapped the assembly in case we need to make any changes. We can keep the same header without changing the assembly, whatever. Screen.c, I added those two print functions without the length. Not much else there. Same thing in the header file. VGA.c, big one for this merge request, deleted all of the copied code, including these register values, which I'm going to have to diff those later and figure out what's going on, and iterated towards now having a graphics register set and get method that takes in the index and takes care of writing to the registers. So there's an address register and a data register, and the steps, to my understanding, are you read the address register first, save it so you can restore it later in case you get interrupted by a service routine while you're doing this. Of course, this is all running in a service routine, which is very bad, but we'll fix that eventually because it's a keyboard service routine, right? Keyboard interrupts. That's not good, but we'll fix it eventually. IO port out, so we select which index we want. VGA has a large set of registers in very few IO ports because they use this where they have an address port for input and output and a data port. So you can set the index by using the address port, and then you can get the data in and out from the data port. So that's all we're doing here with the graphics register. And then VGA info is grabbing some key fields from the graphics register miscellaneous RAM enable, telling us should we be concerned with the memory mapped IO? Should the VGA controller even pay attention to what the CPU is writing to memory? So we want that to be 1, obviously. And then memory map select, there are a number of different memory maps. For VGA is just selecting which one. 0xB8000 is 0B11 or 3, memory map number 3. And then the alpha disable, this was the one that I was looking for. This turns off the alphanumeric text mapping so you can just draw custom stuff on the screen. So this particular bit is very important. Now, as far as setting the resolution, that's a lot more complicated, but it is what it is. So continuing with this, basically just print stuff, and then VGA enter. We set this VGA variable, really just a switch or a latch or whatever, and then it tries to switch modes. It writes all of the memory from 0xB8000 to 0x0010 B8000 so that we can restore it using that cool memcpy command. And then it uses memset to clear part of the screen. And then really we're just messing with the graphics register array. We're setting the alpha disable to 1 and not changing anything else. And then when we exit, I was having some issues exiting. Turns out not only do you have to disable the alphanumeric disable, which enables alphanumerics, you also have to set RAM enable to 1 again and set the memory map to 1, 1 again. Somehow those get reset in the process. And then you copy your memory back and you're done. And then all this copied code I got rid of in the header file and all that stuff. And what else? The tests. I did write some tests for these stdlib functions. I installed ghex, which is a nice tool for exploring hex dumps, and wrote some how-tos in the README. And that's about it.